Google Search Console lit up with 14,000 plus duplicate canonical warnings, and organic impressions dropped 75% in a week. The culprit? Next.js middleware that redirected locales but forgot to update the canonical tag. The middleware-based i18n pattern shown works in Next.js 15 and 16. However, in Next.js 15, the params prop in layouts and pages is a promise and must be awaited. The article uses await params in generate metadata and contact page, which is correct for Next.js 15 plus. For Next.js 14, params is synchronous, so await would cause a runtime error. Ensure your Next.js version matches the syntax used. The article mentions generating Hreflang tags as a server component, but does not show a complete, reusable component. Below is a production-ready Hreflang head component that accepts the current locale and pathname and renders all alternate links with absolute URLs. Place it in your root layout to ensure every page has complete Hreflang coverage. The article correctly warns about content delivery network caching of redirects. A practical production fix is to set a custom response header like xnext locale in Middleware and configure your content delivery network, e.g., Versal Edge, Cloudflare, to include that header in the cache key. This prevents serving a cached redirect for the wrong locale. Without this, users may be redirected to an incorrect language version based on a previous visitor's locale. Let's break down internationalization, i18n in Next.js 16, how it works, and the exact mistake behind that failure. Internationalization in Next.js 16 is the architecture for serving your app in multiple languages. It involves locale detection, URL routing, and SEO signals like Hreflang tags. Unlike other frameworks, Next.js provides zero automatic SEO support. You must implement everything yourself. The middleware is the first line of defense. It checks the URL for a locale prefix, then a cookie, then the accept language header. If none match, it redirects to the default locale. This order is critical for SEO. Here's the middleware code. It checks if the path already has a locale prefix. If not, it looks for a cookie, then the accept language header, and redirects accordingly. Notice the matcher excludes static assets. Metadata generation is a common trap. Next.js caches metadata by URL path, not by locale. If your function doesn't include locale in the cache key, all locales share the same title and description, a disaster for SEO. This metadata function correctly awaits the locale from params and uses it to fetch translations. It also generates canonical and Hreflang alternates. Notice the canonical URL includes the locale prefix. That's critical. Hreflang tags tell Google which language version to serve. Next.js doesn't generate them automatically. You need a server component that renders all alternate links with absolute URLs, and they must be bidirectional. If /fr links to /d, /d must link back to /fr. This component generates canonical and Hreflang tags. It strips the locale from the pathname to get the clean path, then builds absolute URLs for all 12 locales plus xdefault. Place it in your root layout. Server actions don't have access to root params. If you need locale context, you must pass it explicitly, for example, as a hidden form field. The referrer header is unreliable because privacy tools strip it. Here, we pass the locale as a hidden input. The server action reads it from the form data. This ensures the action knows which language the user was using. Static export with i18n multiplies your build time by the number of locales. The fix is to fetch all locale data in a single batch during initialization, using a shared cache. This optimization cut our build time from 48 minutes to 7. This function fetches all locale variants in parallel and caches them with a build-specific key. Each locale's page generation reads from this cache, eliminating redundant fetches. Cookies are increasingly blocked by browsers. Safari Private Mode, Firefox ETP, and Brave all limit cookie persistence. Implement a local storage fallback and always provide an explicit locale switcher in the UI. This locale switcher updates both the cookie and local storage. It also navigates to the new locale path. This handles cookie blocking scenarios gracefully. Content Delivery Network caches by URL by default, but for i18n, you need to vary by locale. Set a custom response header like xNextLocale and configure your content delivery network to include it in the cache key. This prevents serving the wrong language. In Middleware, set the xNextLocale header and include it in the vary header. This tells the content delivery network to cache different versions based on locale. This is the same issue we highlighted at the start. Here's exactly why that happened. Our middleware redirected unprefixed requests to the English locale, but the canonical URL in the layout was hard-coded to n pricing. Every locale page, French, German, Japanese, all served the same canonical URL. Google saw 12 identical pages and flagged them as duplicates. The middleware redirected pricing to n pricing, but did not update the canonical tag, causing every locale to serve the same English canonical URL and triggering duplicate content penalties. The fix was to generate canonical URLs dynamically from params, Locale, and add a server component that renders all Hreflang tags with absolute URLs. After deployment, Google correctly indexed each locale version, and organic traffic recovered within 2 weeks. This was the exact mistake that caused our incident. The canonical URL was hard-coded to the English version. Every locale page used the same canonical, triggering duplicate content penalties. Always generate the canonical dynamically from the locale. Google requires absolute URLs in Hreflang tags. Relative URLs are silently ignored, meaning your Hreflang tags have no effect. Always use the full URL including protocol and domain. Googlebot's accept language header is inconsistent. It often sends NUS even when crawling non-English pages. If you rely on accept language instead of URL prefix, Googlebot will always request the English version, never indexing your translated pages. If you don't include locale as a dependency in your metadata function, Next.js may cache the result across locales. Always ensure your function uses the locale parameter so each locale gets its own metadata. Use these curl commands to diagnose i18n issues. First, check the canonical and Hreflang tags in the HTML, then inspect response headers for content language. Finally, simulate a Googlebot request to verify the middleware serves the correct locale. Let's run through some common interview questions. Walk me through the architecture for serving a Next.js 16 application in 12 languages with proper SEO support. 3 layers. Middleware for detection, layout for Hreflang/canonical, data layer with shared cache. What are common pitfalls with generateStaticParams and i18n? Metadata cache poisoning, build time multiplication, content delivery network cache key issues. How would you debug a 50% drop in French organic traffic? Run curl commands, check Search Console, verify canonical and Hreflang tags. And a few frequently asked questions. Does Next.js 16 generate Hreflang tags automatically? No, you must implement them yourself. What is the locale detection order? URL prefix, cookie, accept language header default. Why does Google show duplicate content warnings? Missing locale prefix in canonical URLs causes all locales to point to the same canonical. Let's recap the key takeaways. Next.js 16 provides 0 automatic SEO for i18n. Canonical URLs must include locale prefix. Hreflang tags need absolute URLs and bidirectionality. Include locale in metadata cache key. Ready to go deeper? Up next, self-hosting Next.js, Docker, Node.js, and deployment strategies, then OpenTelemetry, monitoring, and observability in Next.js 16, then production checklist, security, performance, and CI/CD for Next.js and security in Next.js 16, CSB, taint API, and server actions security. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.